recording. Okay.
Okay.
Yeah. F11 is here. Yeah.
What's it, the full screen, I mean?
Yeah, full screen. Can you make it F11 here?
It's
Yeah.
function.
F11.
Oh, sorry. I pressed something.
F11 function F11. Yeah.
Yeah.
Back. So function F. Did you do function?
Yes, and that it sent it to sleep.
Okay, so it's F11. Yeah. But it's not working. 11 is not working. Oh, just this. Okay, so not removing this. Okay, doesn't matter. Okay, good.
Okay, so I'm just going to backtrack a minute or so. Okay.
Yeah.
Okay, so thank you. So now that it's being recorded, let me just restart. So hopefully, what I'm doing is explaining the rationale behind what we're doing, and the idea is sort of science fiction-y, right? But instead, so it's not feasible to build a real life, fully sized flock of 100 robots that are going to dig up, material to build roads, for example. So what we want to do basically is to make them really small, but still keep the properties that a larger vehicle might have. And what we want to do is sort of use or employ what was not possible 20 years ago when, for example, the Alice robot that I mentioned earlier was developed. So there's been a lot of let's say, development with the new types of sensors that you can buy on integrated circuits, as well as computing power that's available basically in form of a microcontroller. But still, what we want to apply as the principle of solving the task is to learn. So using reinforcement learning, multi-agent reinforcement learning to create these sorts of emerging behaviors. And this sort of thing has not, there have been famous experiments in the past few years. For example, the work that they did at OpenAI, where they've shown that in a multi-agent system, you can have an evolving strategy which only stabilizes after a while. So it was a hide and seek game where the agents that needed to hide and those that were seeking them sort of evolved the strategy as they went. So actually evolved widely improving strategies such as blocking doors and then climbing over walls and then using the physics of the simulation, which was not intended in an unintended way. So actually learn to exploit the properties of the environment, which sort of gives us hope that actually doing proper multi-agent reinforcement learning is a way to go. The other thing that's really been advancing in the past few years, maybe in the past few months, is what NVIDIA has been doing with their hardware and simulation capabilities that you can do on modern graphics cards. So last week there was the NVIDIA's Global Tech Conference, which showcased the incredible progress that they're making with their products. They're doing a lot of things in a, let's say, world that they're calling Omniverse. They've merged the PhysX engine with the Flex engine, and they're calling it the PhysX 5 engine now, which is a physics engine that also includes soft body and particle simulations. But the main benefit we feel is that now you are able to actually perform the simulation on the graphics card and then directly get the data that you need for learning, for reinforcement learning, without the bottleneck of transferring it to the CPU and then back to the graphics card. So these new kinds of environments are really going to speed up the way, the process of learning. And since the physics engines are becoming more and more realistic, as well as rendering engines, this sim-to-real transfer is actually becoming a reality, more so than it was in the past. So very shortly, what has been the progress so far during our short time working on the topic? We've started with a very simple idea of building a modular robot. We've built one using a particular type of connector, which also gave the robot the structural integrity, as you can see on the slide. The dimensions of the robot in the end were 36 by 36 by 33 millimeters, which is actually quite big we intend to make it much smaller, but it's also very expensive, about 100 euros in components. And then it depends. The autonomy wasn't very good because it very much depends on whether you're using, for example, Wi-Fi or Bluetooth Low Energy, or whether you're using the motors or not using the motors. So we sort of abandoned the idea of building a modular robot because it's at the moment just impossible to get to the sort of specifications that we want for this kind of thing. So we want to make it even smaller, we want to make it even cheaper, and we want to make it even more self-sustainable in terms of autonomy. And as well as we want it to be able to perform the execution of what was, for example, learned in the simulation. And we're looking right now at, we're actually building this. It's in the process of, let's say, being designed and manufactured. So we're using the sensors that have only recently become available on the market, which is the STM's VR53L. I'm not sure how it's easier for me to say it in my language, but anyway, the time of flight sensors with a 60-degree angle of where they were able to actually get an 8x8 point cloud, as you could say, or a depth image. But we're also using the Raspberry Pi Pico microcontroller, which actually has a few of the hardware kinks that we think are going to help us with realizing this idea. So actually the figure here, or the picture here, shows the area that's available for different PCBs on the robot, and the PCBs are going to be soldered together. So there is some space to put some, let's say, microcontrollers and supporting periphery onto a robot like this. Now, in terms of software, the Raspberry Pi Pico actually runs TensorFlow Lite Micro, which is let's say, very much a small version or a small part of the TensorFlow environment itself. But what you can do in principle is you can train something fully using a graphics card, using a proper simulation engine, for example, in the NVIDIA's Omniverse suite of applications, but then transfer the learned behavior to a very small robot and run it there on TensorFlow Lite. So, concluding notes, our idea right now is based on swarms as means of emulation. We think the idea is very challenging in terms of the simulation, of course, is easy, but then transferring this and building real-life system based on this is turning out to be really hard. We are building new robots, we are designing new hardware, and we feel that reinforcement learning is the means of actually creating this emergent behavior that is needed for a fully autonomous robot swarm to actually do something with its environment. And the picture at the bottom here is something that we've also seen today. That's part of the research here in Pisa. So Animal, for example, from the ETH robot, well, it's, I think, the first simulation when they've put in this simulation actually 1,000 of robots at the same time. So just to, again, show that this is something that is being done and is currently the state of the art in terms of the scale of simulation, we feel very confident in pursuing this idea forward. So with this, I want to thank you for your attention. Hopefully, if you have any questions, I don't know, Michael, if the time is now, or do we?
Yeah. My suggestion is, thank you very much. My suggestion is that we postpone all the question to the end. We have time. Yes. So we will have time later. So those that can connect via computer or stay in person can ask question directly. And I suggest Marco come by the way to provide this presentation, which is what we have here. Can you find it? It's open, so you can check. Yeah, here it is.
Okay.
So, thank you, Marco.
Thank you. Hello, my name is Marcos Zoran. I'm an assistant researcher at the University of Ljubljana, Faculty of Mechanical Engineering, and I will present today a new concept called shared manufacturing. So first of all, we will go through the overview of the presentation. I will introduce you first to the sharing economy, which is a broader area of in which the sharing manufacturing is derives from. Then I will represent you the shared manufacturing concept and where the blockchain is included into the shared manufacturing, and my colleague Nate will then present our current state of research on this topic. So, sharing economy is a very new concept. It's been utilized by Airbnb and Uber. So, if you look at this, figure here, we can look what the Airbnb did with the offering of rooms. So they ask themselves, people need place to stay somewhere, okay? And why not use empty rooms in people apartments to try to use these unused spaces for people to use it. So, and the same thing were done by the Uber. Why not use personal cars as a means of transport instead of taxis? Okay. So the main principle here is utilization of unused resources that already exist in the system. So the same thing goes for the shared manufacturing concept. We ask ourselves, do we need to manufacture some unique product? And through the platform, which is currently not in the form of Airbnb or Uber or something like this, we can then use unutilized machines and devices in the current production systems and try to build our product. Okay, so if we look at the demonstration, how would this look? We have a mechanical manufacturer A that produces nuts and produces bolts. And we have some other manufacturer called B that also produces nuts and bolts. And for example, there is an order of 100 nuts and 100 bolts that must be completed in 2 days. So somebody wants this order to be completed. And in this case, manufacturer A have a production of bolts being occupied currently. So he cannot fill this order by himself. And same goes to manufacturer B, he also cannot complete the order by himself. So if you look at the other production processes, we can see the production of nuts in manufacturer A is currently idle, and so the production of bolts in the manufacturer B is also in idle state. So if they work together, they can complete the order. So they complete the order with unutilized resources in their factories. This is the main concept of shared manufacturing, and the transformation of classical manufacturing to the shared manufacturing is done with the usage of APUs, so autonomous production unit, we call them. If you look at an example of a mechanical manufacturer, APU could be a production unit that can produce nuts, or production units that can produce bolts, or if we can go one layer down, we can also use machines that are used to produce nuts. So machine for drilling and some or 3D printing, and also the resources can be persons that operate machines. So everything is disassembled to the smallest part, and then it is used as an autonomous production unit. So. And the same goes for the production of bolts. It can be arranged in this way. Shared manufacturing platform is then assembled with these APUs. So the shared manufacturing platform is actually communicating with all the APUs to try to produce the end product. So the order will be completed if, I don't know, these three will produce things that they were ordered to. So maybe another thing, they operate on the basis of demand and offer. So shared manufacturing platform demands something from them, and then they offer if they can do it and for what price and the timeline. So why we need a shared? It's another problem.
Yeah, because we are not sharing the right screen. So we need to switch here and
Okay.
share something else. So one window, this one. Yeah.
Okay. I just continue.
Yeah, you can record something if you or show something.
Show something that is okay. I'll just show here. This is the example of how shared manufacturing works here. Okay, again, we have an order of 100 nuts and 100 bolts. Manufacturer A could produce this order by himself, but currently his production of bolts is occupied, and the production of nuts is not. And the same goes for the manufacturer B. The production of nuts is currently unavailable, so the order could not complete it in 2 days. But if they have both of them, they have idle production of nuts and production of bolts, so they together could fill the order. So they just through the sharing platform, shared manufacturing platform, they can complete this order with the usage of unutilized production units. Okay, the basis of shared manufacturing concept, the basis of shared manufacturing is an autonomous production unit. So here I will show you what this means by transforming traditional manufacturer to the autonomous production unit. So one unit could be production of nuts as a whole and production of bolts as a second production unit. But we can also offer these lower level devices. So a drilling machine or a 3D printer or a person that is actually in the process of production of nuts. Okay, so all of these processes can be utilized as APUs. Shared manufacturing platform is then it looks like it connects APUs in one system, and the production is done actually on the APUs, and shared manufacturing platform is just here to control the production of the and communication of these APUs. In the next session, I'll introduce you how the blockchain and shared manufacturing is connected. So the shared manufacturing platform can be built using blockchain technology because blockchain technology enables connection of parties that don't trust each other. This is the most important part. For blockchain, you need the parties that don't trust each other. It is a decentralized way, some decentralized system, so it is operating in this fashion that can connect to parties that don't trust each other. The blockchain handles the payment in a decentralized way, and it handles also the binding agreements between APUs. So APUs communicate with demands and offers, and the blockchain can also can also follow these agreements and store the states of them. It enables uncensored, immutable track record of APUs activities. This is very important. If you have a history of activity of APUs, you can then, based on that history, produce a rating system or a reputation system, how reliable some APUs are, and if you would like to, in the future, work with them or not. And also ensures a democratic access with public listings of available APUs. So on the blockchain, we should have a list of APUs that offer certain services. So for example, a list of 3D printers, a list of designers, a list of programmers or something like this. This is a public list and anybody can be on it and offer those services. Colleague Nate will now continue with the current state of our research. Okay.
Okay, yeah, thank you. My name is Nate, and I'm a PhD student, a colleague of Marco. Basically, my research is oriented towards the blockchain-based shared manufacturing. As you have seen, the concept is quite multidisciplinary. Oh, yeah, thank you. The concept is quite multidisciplinary, so you can also look at the concept from different perspectives, like socio-economical as well as technological, and also there is a manufacturing part here. So I'd like you to show you what kind of methodologies and theoretical background or theories we have used so far in our research. Okay, so basically, first of all, we tried to analyze how would blockchain technology affect the manufacturing aspect of this concept. Basically, blockchain technology, as all technologies, have some limitations as well as advantages. And in order to research this question, we didn't have any kind of existing system because this concept is like 1 year old, and there are no manufacturing systems that support this kind of concept. So basically, we kind of have to use tools from the experimental economy. The idea here was basically to create a virtual environment or simulation in a form of an online game, where we put all the properties of the concept inside this virtual environment, and then we try to incentivize players or human players to act as they would if this concept would exist in reality. In normal experimental economical systems or experiments, usually the incentive is money, but we used our students and we incentivized them with some student credit points. Okay, here on the picture we can see the game. We tried to simplify the concept as much as we could do it. We divided the players in 3 groups. Each group provided one type of service. They were basically the owners of the APUs, of one APU, and they provided their service on the market, on the global market, which was connected to the blockchain network, which was ensuring which was ensuring the financial platform, basically. The point of the game was to upgrade your manufacturing system as best as possible. And the upgrade, you could upgrade your APU by buying the other types of services. For instance, you had like 3D printer, and you upgrade your software, and basically you could provide service faster with higher frequency. Okay, the manufacturers here could also be the maintainers of the blockchain network. I don't know how much you are familiar with technology. I wouldn't go too much into the details, but in blockchain network, you have to have some nodes that are keeping track of all financial transactions, and by doing that, they are rewarded with some transaction fees. Okay. Okay, these are the results. First of all, we conducted the experiment with 27 students. They played the game for 1 hour and a half. Basically, these are the settings that are dependent on human nature. So people cannot be focused for more than 1 hour and a half, and also the user interface had to be specially designed in order for them to learn as quickly as possible about the system and try to use them as if they were already known with the system before. Okay, so these are the results. We can see first. You can see the transaction fee. The transaction fee went from some random number. It went down because of the amount of transactions was lower than the frequency of the blockchain, and because of the properties of the free market, it reacted the same way. But once the production systems start to upgrade themselves and increase their frequency, the transactions clogged the blockchain network and increased the transaction fee. Why is this important? If we look at the results of the price, we can see that again, first of all, the demand was higher than the supply in the first half of the game. But after the supply got better and faster, the prices starts to turn around and they lower. And at the point at the 3/4 of the game, the prices for service were exactly the same as the transaction fee, which is not ideal in the manufacturing systems. And these are the limitations of the blockchain network and blockchain technologies. Okay, you can see also the order book here. The amount of services in the order book correlates with the conclusions we made on the previous two results. We are also interested in the balance or the money flow in the game, and we saw from this distribution that at the beginning of the game they started with the equal distribution of the money, but during the game some of the nodes got better than the other, as it is normal in such systems. But we were not sure this was the reason because of their production strategies were better, but because of the limitations the blockchain technology inserted them in the manufacturing system. And that's why we try to analyze this experiment using network theory, which is one of the theories that could be used as a tool in this kind of setups, experimental setups. I don't know how much you're familiar again with the network theory. It's more IT field where the interactions in the system between entities are studied using graphs. In this research, we were mainly interested in the organization of the network and how the nodes are connected between each other. There exist many models of how networks or nodes are connected between each other, and one of the hypotheses here was that scale-free network would emerge, and the distributions before already confirmed some of these hypotheses, because in the scale-free network there are some hubs with a lot of with high in-degree, or in our case the income was much higher than in the majority of other nodes. And the distribution here follows the power law, and that's what we were looking at in the results. So basically, our network here was money flow network, where players were connected with the flow of the money. The main source of money was selling the services, but the other source of money was also collecting transaction fee from the transactions. And this was our main result. In the red line represents gamma coefficient of the power law. As you can see that during the game, the network was at the beginning randomly organized, and this gamma coefficient is quite high. And then after the network got congested, the network organization became to organized as a scale-free network. And unfortunately, our experiment was not long enough to actually show that this gamma coefficient would go towards the values which define scale-free network, but we are working on the simulation which would help to extend the experiment even longer, so we can actually prove the hypothesis. Okay, so these are basically the results of the game and also the simulation we programmed. The blue lines represent the theoretical manufacturing capability of such system, and the green line represents the actual manufacturing capabilities. And the orange line is the frequency of the blockchain. As you can see, the blockchain network works as some kind of low-pass filter. And at the end of the game, such manufacturing systems operated only at the 40% of the maximum capabilities. And this is a problem in manufacturing. So basically, our next research is oriented towards increasing the scalability of the blockchain network, which is one of the main limitations of this technology. We actually already published one paper where we proposed one solution. It's a special sub-technology in this field. I wouldn't go into details, but you can ask me later. Our simulation also proven that if we would increase blockchain frequency, the actual capacity or actual efficiency of this manufacturing system would increase. And we hope that our experiments will prove this hypothesis also in the future. Basically, I presented only one methodology and one theoretical approach how we could analyze such systems. Why is this necessary? In first place, the existing manufacturing systems and the manufacturers are not so keen to accept new solutions. They rather see it tried in other companies, and if they are successful, then they like to copy. So the rigorous and efficient analysis is needed in order to convince them to even integrate such systems. And that's why we are using this kind of simulation tools and experimental economics. But here we can study also many different aspects of it. For instance, we can also study the whole manufacturing aspect of organizational problems. How can we manage APUs in the manufacturing systems and that are working simultaneously in the local environment and also in this global kind of network. Here we also have the aspects of game theory that could be applied and used for analysis of different strategies of the players in this kind of systems. So basically, these are all good points to start researching this kind of field. But as I said, it's quite new topic, so not many research has been done already on this topic. This is basically all from my side, and yeah, I think it's time for the questions, right? Okay.
Thank you. This is a very challenging and original topic. So, and by the way, we are planning to cooperate on this already. So, other people are welcome to join the party because the topic's not so obvious. And so more ideas are welcome. So, and here is the boss. I'm very pleased to give the word to Primoz. Yeah, you can launch the presentation and I check if it works ahead before we make more mistakes. Great.
Okay, this one is
So, launch it here. Let's see if it goes where it should go. Check.
give the thumbs up.
I think we need to share it. Yeah. So we need to go back.
How do you?
So we need to switch. Is this computer with 3 screens? To go to Meet. Stop sharing and share again. So stop sharing. Right. Stop. And then share again. Window. Yeah. Yes, here, this one. Perfect. Yeah.
Just one thing. So here, so
Yeah,
I
yes.
go. Yeah. Okay. I can start. Okay. So now let's go to the next presentation, which is titled "Remote Photoplethysmography." So my name is Primož Podržaj. I'm from the same lab as the other guys from University of Ljubljana. And this is one of research topics that we are also involved in. So maybe the name is not so familiar for a wider public and needs maybe more thorough presentation. So as you know, nowadays, especially during the COVID pandemic, it's a very large emphasis on the technologies that help monitor person's health. And one of the possibilities is so-called photoplethysmography. So it's a method or technique that assesses vital physiological parameters based on some wearable technology. Usually this is done by LED, which you are very familiar from sports watches. So the problem is that in certain scenarios, this is not a good solution. So recently, RPPG was developed. So this R in front of the abbreviation means remote. So in this case, that means that these physiological parameters can be monitored without any contact. So some also translate it as a contactless photoplethysmography. So the most typical setup during the research is that you use a kind of camera, a light source, and a subject, and you take a video of the subject, and the goal is to get some physiological parameter. The most typical one is the heart rate. So how can you do it? So you know, with your naked eye, you basically think that a color of a person doesn't change, at least not due to heartbeat. But if you go into more detail, so that you have a camera with a high precision and you amplify variations in color, you would see that the color varies with heartbeat. And the idea is to extract this signal from the measurements. So how do you do it? So in this scenario, where everything is perfect, so you have good lighting, the subject is sitting still, the camera is pointing into his face, it can be done with quite a good precision. But if you go into some other scenarios, so maybe not so good lighting, shadows present in the video, the subject moving, let's say cycling, or let's say experiments when someone is running on a treadmill have been done, then this is more complex. So basically, the research is divided into two areas. So first one is image processing. Within image processing, the goal is to detect the area of the person, usually it's the forehead, where the RGB signals, the raw RGB signals are the most precisely extracted. And then the second part is basically signal processing task, which has to get the heartbeat from raw RGB signals. So myself, I come from a control theory field, and when we were doing this research, we were thinking about possible applications of this approach. And the idea is that in a control loop, usually human is not an object, but with photoplethysmography it can become. So basically this is a feedback to evaluate a physiological state of a person. And somehow in various scenarios you can get person to be controlled by some kind of feedback. So the ideas that come in mind are, let's say you are familiar that during the COVID pandemic, all the lectures were performed online, at least in, I would say, majority of countries. And you know, one of the drawbacks was that the lecturer, for example, had no feedback. Are students stressed? They don't understand the topic being presented during the lectures. And if you would have some kind of system that could evaluate maybe 100 students at the same time and give feedback, let's say, in maybe some scale, let's say students on average do understand the lectures or not. It would be very helpful for the lecturer, you know, to adjust the, let's say, the complexity of the lectures. So, you know, experienced lecturer, you know, when he sees the students, he knows, do they understand or not? If you are doing the lectures online, this feedback is lost. So with this system, this could be improved. Also another topic that could be addressed, let's say you have a software, let's say you do some programming and help, you know, all the, let's say, development softwares have some help, but help is independent of what you, how to say, your state. If a software would have this implemented inside, the help could be adjusted to whether you, how to say, you are stressed or not. And actually the last part that we are currently doing research in is whether students during exams, if we monitor them, can we predict the grade or not? So we were doing these experiments and we are still conducting research whether there is some correlation with physiological state during the exam and the final grade the students obtain. So I will not go into too much detail within this presentation because I'm, how to say, I don't know whether the audience has some background in it. Here are some papers that our group published, so maybe you can check and if there is some, if there are some questions after all of these presentations or later, it's no problem to contact us. Yeah, so questions, as Michele said, will be posted at the end of all of these presentations. Now I need help of Michele. Yeah, so this one was like a brief one.
So, yeah, so this is our project, which came from a very interesting idea and provided also very good results, I think. So I'm very pleased to announce the last but not least presentation. Oh, we need to share, right. So we need to move, sorry. Where is Google Meet? This one. So we need to stop and share the new one. Perfect.
Okay, thanks. And I think here, now the view, I think it's not okay. Where is the mouse? Usually it's not like this. For me, it's no problem, but you know.
Go on.
So they, okay.
Oh, you want to see the preview?
Yeah, if it's...
Probably this one?
Yeah, it would be better. Okay, and the second presentation is about the interactive course for control theory. It was a project, an Erasmus Plus project. So I will give a brief background into Erasmus program in case you might find an interesting topic that would be suitable for a future project. Okay, so Erasmus projects are in general focused on learning. So it must be something that does relate in some or other form to learning. So all the details are in the Erasmus Plus program guide, which is like a booklet with 300 plus pages. And if you need all the details, you should read it. It's impossible to present everything in such a short presentation. The calls are basically divided in 3 key actions plus Jean Monnet, which is more like involved in European Union. So the last one for us as engineers, we can forget it. The first one is about mobility of students or personnel, also not that interesting. So the main part we are interested in is the key action 2. The key action 2 supports, as you see, many types of partnerships. The one we were involved in was cooperation partnerships. And of course, always when you think about submitting some project proposal, it's important that you address the priorities that are given in this program. So here are several of them. I didn't go into all of them. Our project was involved in addressing digital transformation through development of digital readiness, resilience, and capacity. So this priority is for all fields. And then you have sector-specific priorities because our application went into higher education. So we also had to choose some priority there. And let's say, I also, again, didn't put all of them here, and our project addressed the priority titled Stimulating Innovative Learning and Teaching Practices. The project duration can be between 12 and 36 months, so means between 1 and 3 years. And the total grant you can get is 400,000 euro. So the grant can be used for project management, transnational project meetings, multi-prior events. So basically that means events that present the project results, and some exceptional costs, which are, I would say, if you have some material used, but you know, this should not be a major part of project. The main funding goes for project results. So in our case, as you will later see, it was an interactive course with accompanying handbook. And the amount of work days used to produce this result is project cost. And this is where the main funding was used. Okay, so like maybe the second item is not so important here. So, you know, when you go into project proposals, it's important that it's well balanced. So that means that all the partners have some role. At least 3 of them from 3 different countries have to be present. So the funding also depends. So if a person from, for example, Bulgaria does one work day and someone from Sweden, you know, like the person from Sweden is paid like more than 3 times as much. So the project doesn't need to be balanced on money, but has to be balanced on work days. That's the idea, because you know, salaries throughout the Europe are that different. So I just gave a brief overview of the proposal. Of course, like if I wanted to talk about everything, it would take too much time. So our project involved 4 partners from 4 different European countries. So Ljubljana, Slovenia, Rijeka, Croatia, Pisa, Italy, and Budapest University of Technology and Economics from Hungary. So even before you submit a proposal, you have to, actually in the proposal, you have to prove that what you will do is really needed. So in our case, we did a survey regarding the lectures of control theory. So our assumption was that it's more difficult than other lectures students take. And another question was, what would be your, of course, the survey was answered by students. So we were asking them, what would be your preferred way of studying it? And the results clearly showed that the topic is more difficult, and that the most suitable way of studying it would be interactive course. So our main goal was to develop this interactive course. The whole project was divided into several project activities. So as you see, first we analyzed what kind of framework can we use to develop this interactive course. Then it was actually developed mainly by partners from Rijeka. All the other 3, so Ljubljana, Pisa, and Budapest, prepared the interactive exam examples, and frequently asked questions section. Then, of course, during the project, we did the testing of beta version of the interactive course, where all the, all the problems were detected, so that we could improve the user experience, stability of the whole platform, and so on. Then we also prepared the textbook or handbook accompanying the interactive course. One of the demands of the Erasmus Plus project is that the results are available in the languages of all the partners. So that means that we had to translate the course and the handbook from English, which was, the language that the course was initially made in, into Slovene, Croatian, Italian, and Hungarian. And of course, the last step was the final testing. So the ICCT platform has several advantages. So no installation or any specific software is required. It offers fast and easy updating and upgrading of the system and the contents. So it offers easy collaboration on content creation and centralized authentication and authorization. And it is accessible at the page you see here. It's actually on the server of University of Pisa, because they have, the best equipment from or among the partners within this project. So maybe just one more thing, how we divided the tasks regarding the examples and all the text. So University of Rijeka, because they were mainly computer engineers, did the mathematical background. University of Ljubljana focused in time domain, Budapest University of Technology and Economics in frequency domain, and PISA in state space. So also, if you look at any control engineering book, you will see, so in some, these topics follow in sequence, and some books even go in parallel. So in analysis, they do all three approaches, and then also in control system design, the same. Of course, there are many examples. I will present here only one. So, for example, water level control. That even though you are not from a control engineering background, you can understand this example. So the idea is that you control the water level in the reservoir, and below you have three sliders where you set the reference height, the amplification, system amplification, and this is the outflow of the water, which is disturbance for this system. The disturbance is the opening of this globe valve. The amplification can be adjusted by moving the support of this lever and the reference height with the length of this part of the, how to say, the length of this rod above the float. And of course, then you can change this in real time. Actually, I have a video here, but I'm not sure if we can try and then we can do
So it was here.
Yeah.
So I have to move it.
So this is how the.
Sorry, I need to move it.
Here.
No, I need to exit the presentation, and then I move this. Sorry, how can I move it? See if it goes on the screen. Yes. There's audio also.
No, it's no audio.
It's just video, perfect.
Yes, video.
No, it's here. There's some audio.
No, it's not this.
It's not your video.
No.
What is this? What is this thing? Oh, let's try again. So this is the video. Yes.
Yeah, this is the video.
So here we see how the thing works. Resolution problem, and we need to share it as well online. No, it's not. No, this is different thing. It's another project we are doing. So let's try again. It was too ambitious to show the video. That's right.
Yeah, that's why I was not sure whether to do it or not. No, now it works.
It works.
Yeah.
Oh yeah.
So.
But we need also need to share it. I want to share it online so that everybody can see. So we need to stop share one window, and the windows is which one?
I don't know where you put it.
No, the movies. This one.
Yeah.
Okay. Let's go back. You want to comment?
How to say? I'll do a brief. So this is how the ICCT looks like. So with many examples, you can you get the code. Usually it's like a short text about the example. If some sketches are needed or figures are also added, and then you get the example, so interactive example. So in this case, you see the reference level and the actual level of the water in the reservoir, and then you can move the sliders and see the response of the system. So now the KP changed, so the support was moving when the reference is, or now it's the outflow. You see the blue dots at the outflow reduced in the number, so that, how to say, we try to make sure that the outflow is decreased. And if the reference height is increased, the length of the rod about the float will also vary. That's the idea how the system works. So there are many examples. You are really invited to try and see for yourself. Okay.
Yeah.
Basically,
That's 100 examples.
Yeah.
Very many examples.
So Michele was under stress when he had to develop the
He was very demanding coordinator, project coordinator. Yeah, very, very nice experience and free material for students.
Yeah, so that's
you are
another
welcome,
thing
the
that
students are welcome to test it.
Yeah, that's another
To use
thing
it.
that I forgot to tell, and it's very important. Everything that you develop within Erasmus project has to be shared for free, so cannot be sold.
So those
everyone-
that took a control theory course some years ago may discover something that they will never, they didn't know they know already.
Yeah.
So you will see under another, shed another light on your knowledge about control theory. So I think that's it. So we can have one-to-one questions. So there are many presenters, and so I think we can first of all ask if there are questions online. So we give precedence to those that are online that are not here, and then we will close the meeting. So yeah. No, it's fine. It's fine.
You are the boss.
So yeah, maybe I can just spend very few words for the students. So if you are interested, no, parlo in Italiano, I speak in Italian. Quindi abbiamo un accordo, si può riattivare anche l'accordo, ma per tesi di laurea non serve l'accordo, perché c'è un programma Erasmus che permette di andare con borsa di studio. Quindi se avete interesse a fare una tesi a Ljubljana, si prende contatto, indicate l'area di vostro interesse. You can provide topics based on what are the interests of the students, and if there's a match, ci sono due scadenze, marzo principalmente. Quindi da qui a marzo potete fare domanda e le borse che vanno deserte vengono ribandite a settembre. Quindi per partire entro l'anno successivo, entro i 12 mesi che seguono. Triennale, dunque, tesi di laurea è una possibilità. L'altra possibilità sono gli esami, quindi si può andare per esami, però per esami ci vuole l'accordo. Quindi se c'è un interesse, si individua una... Sarebbe, sì, sempre Erasmus stiamo parlando, però Erasmus ci sono 3 programmi diversi. Per le tesi, poi ce n'è uno che si può andare per qualunque motivo, si possono fare anche in azienda, qualunque organizzazione che non ha anche un accordo. Invece per i corsi ci vuole l'accordo, è il terzo programma. Però siamo in fase di rinnovo, quindi se ci interessa andare, lo segnaliamo immediatamente all'ufficio, rinnoviamo l'accordo e così siete coperti, scegliete i corsi e poi si va nella procedura normale, dipende appunto da quanti e quali crediti volete frequentare e si verificano il riconoscimento da parte dei docenti, diciamo di qui, che guardano il programma, verificano la fattibilità. Quindi potete fare un giro sui vari corsi di studio analoghi e vedere che materie ci sono e provare a concentrarle in un semestre, per farne 3 o 4, insomma. C'è una mano alzata, C'è ingegneria. Do you have mechanical engineering? You have programs in... They are from mechanical engineering, so they are the equivalent of kite, pallottino. Just for do you have industrial management engineering as well?
There is inside
Inside mechanical engineer there is so you can find the topics. You don't need to, non deve trovare un programma, deve trovare gli esami. Se gli esami sono equivalenti come crediti e contenuti, viene riconosciuto.
Now, basically, also for our students, how to say, go to one of the four main majors. Yeah, we go to one of four majors that gives you all the count of the exams. The other count whatever you do. So we have a lot of things.
Thank you. Yeah. There's a question online, Antonio ha alzato la mano, può intervenire, non la sentiamo perché. Why don't we hear you? Maybe I need to turn on my phone because from the computer it doesn't come out.
Can you hear me now?
Yeah.
Okay. So first of all, thank you very much for your very interesting presentation. They were very, very interesting, cutting-edge topics. So my question was about the photoplethysmography. Excuse me. Okay.
Yeah.
About photoplethysmography, because it seems that it has some. It can be used not only for health monitoring, but also to interpret the body language and really what crossed the mind of
body language.
Of the people that
Can
are
you write in the
monitored.
chat? Can you write in the chat?
I write it in the chat. Okay, thank you.
So the technology of this room is at 1920. Stopped since 1920. Yeah. Okay. There's maybe in the chat there's something. Elisabetta domanda, scrive in chat. There's one yes. I don't know. Maybe former question from before. Okay. Can you hear? Yes. So it's yes. Okay. So maybe Antonio is writing a question. It's about a research topic. So maybe more easily I can. Antonio can call my phone number and we can talk. Yeah. So those that watch this video from the YouTube channel, they can forward their questions to the presenters, and they will help support for cooperation and student exchange and so on. So let me take while we wait for the last question. Let me take the opportunity to thanks again for your visit, for your presence here, and hoping that our cooperation will increase and extend more and more, and invent more solutions for teaching, as we did with ICCT and for everyday life. Oh, here's the question. Looks a question for Primož. Can you read?
No, because I need glasses.
Maybe here.
Seems to be. Yeah, how to say?
Sure, please. Have a seat. You can proceed and provide your answer. Yeah, this one.
Yeah, maybe I can read the question. So photoplethysmography seems to be very promising also to interpret the body language and what crosses the mind of monitored people. What are the implications in countries where a lot of monitoring systems are employed? For example, China. So I would say, there are already algorithms, but not RPPG based, which involve emotion recognition. So actually, we were also considering that in our research. What should I answer? So, how to say, knife can be used in kitchen or to kill someone, but we still need it. So, of course, technology can be misused, but that doesn't mean that, the progress shouldn't be made, in my opinion. So it's very difficult. So if someone wants to use it to monitor people, of course, it can be done. But not all the aspects of this can be considered to be malicious, So, for example, if in the airport you would be able to detect, for example, a terrorist, I think it's beneficial for the society, not always like in a bad manner.
Yeah.
That's my opinion, at least.
Okay, so I think that we are done with the general purpose question. So I close this very interesting and rich session. Maybe the presentation will be available. We can share them. You do have a question, oh Mark? Couple. Oh, great. Please have a seat here so they can see you. It's the project that was presented finished the last August. So it was. So we do have the textbook, 150 pages, 150 examples, interactive, frequent asked questions, and material for teachers, everything. And it's written in. Did you say it's written in Python?
Yeah, that was going to be the next question. Because I noticed Python. So is that you're running on the server side?
Yeah.
Running with Python. What made you use Python instead of Java or something else? What was the reason?
So we did an extensive research.
Yeah, microphone. Yeah. Yeah, maybe this one.
I give it to you.
Yeah.
Thanks. Okay, so maybe I'm not the best possible person to answer that question, but one of the project results was the analysis of which framework is the most suitable for our purpose. So it was mainly done by partners from Baker, who are computer engineers. We just gave the input what we want from the platform. At that time, it was decided that it's Python.
Okay.
So.
A short answer can be in control theory. MATLAB is used very much, and Python is the free version of MATLAB. So since that to be open, we thought it could be a success.
Exactly. No, it's interesting to me because the course I'm teaching right now, my examples are in Python, but all the students are like, why couldn't you do it in MATLAB?
Yeah. MATLAB, yeah. It's a little simpler, yeah. True, very true, absolutely. Yeah.
I had also a question about
Microphone, please.
you mentioned that it uses a light source. Is it visible light or mostly infrared?
Visible.
Visible. Yeah. Visible. And how much is it affected by skin color of light?
Yes, it is, how to say, let's say, with
Microphone?
it doesn't work as well as white. There is, how to say, there is performance is not the same for all screen colors.
Thank you. Okay. Yeah. Very, very, very good. So, should I close the session now? Okay. Thank you again. Thank you very much, everybody. I've stopped the recording. And leave it on. Right. So now we have to figure out this blockchain thing. So the tough part starts now. Because we are thinking to, so at 7 you're busy. You can show you have a big office in Italy. So you can until 10 to 8 you must go. So if you okay. We can walk there. So we will walk from here.
Yeah, and so I just, if I'm running, if it runs all the way to 8, then I'll just.
Yeah.
You're at,
I think we are staying here. Yeah. No, we can go from here. We wait for you, no problem.
Well, if I.
Okay, good. Okay. So 8 to 10 to 8 they close. So you need to make it because otherwise the girl will get a lady from the
Yeah, maybe the box would be better if you're not going to use it. Using, what are you going to do? Are you going to use it on?
No, I think we can say in this building. We can say in this building and but they close the rooms. The office is for one person, maybe we can use yeah, we have to figure out this blockchain application in where Thomas
Okay, well, the other
Thomas
possibility, if there's like a, it's really next to your office or your office or anything like that.
yeah, no, we will not fit in my office.
Yeah, I suppose.
So we are staying in the first floor, maybe. So we can move over there. Where do we want to go? 10 to 8 they close here. Mark will need to do his conference until 8. There is
So we can wait for you outside.
yeah, so we go in the next go back to the department. So Mark can stay in the office and we stay in there's a room, classroom in the first floor.
So we can
Because here at 10 to 8 they start chasing people.
Do we need Michele to turn off the equipment?
Yeah, I can quick turn off the equipment and so turn this one off. Yeah. Okay. This one go here.
Michele, do you know the height of this hall?
No.
2 stories. 2 Italian stories.